I think one of the things that's unique about KFest in that we have enough sessions that we don't have too many. We don't have to do multi-tracks. You don't have to choose between one or the other. But we normally haven't gone into the evening as much with sessions. So, but as we get more people who volunteer to do them, we'll try to squeeze things in. So this year we're actually doing extra in the evening, and we're going to start tonight, continue from Rob's session that just happened with Geoff Weiss doing behind-the-scenes tool sets on the Apple IIgs.
Okay, thank you.
Thank you. My name is Geoff Weiss, and I'm an Apple IIgs developer, among many other things I have done with the community as well. With the Apple IIgs being the top-of-the-line computers in the Apple II series, the Apple IIgs will get this technology, and sort of cool. Looking here 20 years later, 25 some odd years later, that looking back at what was done with computing at the time, and appreciating what was done. Toolsets, typically, as we know, are usually provided by Apple and gets installed in the System Tools directory on your disk. And tools are loaded dynamically. Obviously, the tools that load dynamically are those that are located on drive. Tools that are in ROM don't have to load because they're in ROM, but they don't get started until an application does start that, and we'll explain that. I'll talk more about that as we go on. Tools have there's several different functionalities that tools provide, and tools are the most prevalent use for tools is the user interface for the Apple IIgs environment. Apple has pushed the concept of you want a unified look and feel of your application, and by using the Toolbox API provided by Apple, then you're be certain that your applications have the same look and feel across the board, made by multiple developers. The tools also touch on drawing, and with the IIgs, G stands for graphics, that's for sound. So obviously there are tools that are highlighting graphics and sound capability, and there are some tools that are designed to access the hardware. So this gives a chance for Apple to modify hardware for future planning the Apple II series of computers. You can modify the hardware, but as long as you use the tool interface, then it doesn't matter what the hardware. If the hardware changes, if you use the tool calls, then you know that your programs will always work. Granted, the IIgs was technically the last computer, and the multiple revisions of the IIgs weren't that much different. Mostly not that much different across the board. So so if you do use write to the hardware directly, most likely your applications still continue to work. Obviously, we've seen some demos that had failed, that were written for the ROM 0 and 01, and see that they did fail the ROM 03, but generally the hardware was mostly compatible. There are two types of tools that Apple has documented. You have system tools that are provided by Apple, and there are user tools, which are the third-party developers for developing a tool type of interface. And I'll be touching more on user tools in a little bit. Each tool can support. So the system itself can support up to 255 system tools and 255 user tools. Each tool set can have up to 255 tool calls, and hence the joke at the end, for understanding the concept of toolboxes, tool sets, and tool calls. Any questions so far? Yes?
Was the idea of the toolbox brought in when they, was it brought in at the same time or as part of GSOS System 6?
Tool calls were around ever since the IIgs was originally developed. So in the System 1.0, if that ever actually did get released, tool calls existed. So at every IIgs The ROM in the 2GS has tools as well. So when you think about it, when you bought the very first Apple IIgs off the assembly line in 1986, it had tools built into the ROM, which meant that Apple had to have been developing tools for some period of time before that computer was built. So this has been something that, so tools was being developed internally by Apple for a period of time before hardware was even made. So for all practical purposes, it was around for the entire lifespan of the development of the computer and today.
Give us an example of a third-party tool and how it was implemented.
Great question. I'll answer that now. That was sort of more purposeful a bit later, but I don't mind.
Later we can wait.
I don't mind. I'll sort of answer half of it now and half of it later. A lot of people who had made, so tangenting from that question, first of all, many of the tools that we have seen released over the years, and over the years is usually, back in the 90s, and let's say, in the past 10, 15 years, most of the tools are system tools. So FTA did a tool 219, which is for audio music playing. So most of these tools are actually system tools. I only know of one example of a user tool. There's actually a few user tools. The first one I thought of was the Clay M tools, which was for MIDI music generation, and that came with some music programs. And two other examples of user tools came with ByteWorks development. One was a joystick routine, and the other was some sort of, I think, a time routine or something. But most people tend, except for the Clay M tools, was the one that, if you download this one application, you had to have that user tool available as well. And that's why that was the first one that jumped out at me as remembering of existence. I don't know if anybody actually used the ByteWorks user tools for any applications. So I basically answered half the question now, and do the second half as we get to the user tools part. Any other questions so far?
Is there a difference writing a user tool versus a system tool, or simply the number that you choose?
Great question, and that was going to be very, very lightly covered later on. There's a slight difference. Yes. Now, basically says a slight difference, but yet it's mostly the same. Any other questions? All right. System tools. System tools are found in the ROM of the computer. The ROM 00 and ROM 01 have the same number of tools. There are 12 tools that are developer accessible. I wasn't certain if one or two tools were actually in the ROM or not, but there are some that are marked reserved or programmers not to ever touch. So I didn't care. I pretended that didn't exist with my numbers. And then the ROM 3 has 21 tools available, 9 more than ROM 1. So hopefully I added that correctly. And there's a bunch of RAM tools that come with the system disks, and those load from disk when an application does call them. If an application does not try to start that tool, then it will not load from disk and will remain on disk and not in your memory. All right, so sort of tangenting around with several different concepts here to develop time. The application. So when an application calls tools, so we're sort of so we now sort of finished the basic introduction to tools, and we're going to jump into how an application uses tools. So I sort of actually didn't document, the tool calls, say load one tool or load tools. There's tool calls to use to load tools. So the first tool So somewhere I have to start at the beginning. So the beginning is the tool locator, which is tool number one, and I'm using decimal numbers, so tool 001, where a tool can be 255, so it can be up to 3 digits long, so I'm using 001. Apple's naming structure in their system tool directory is tool number, or digit rather. So the tool locator has no dependencies, and you need this tool you first start this tool, and then this tool has a tool call to load all the other tools, or load tools and basic Toolsets tool call management. if you're going to be loading tools, that's the first tool you have to call. Then another popular tool that you pretty much need for development is a memory manager. So you can allocate memory. That's tool call number 2. And tool call number 2 has a dependency of the tool locator, which is what I'm showing here. This is just a few examples. 2GS technical note number 12 has all the details, and I actually have a copy of that here, so we're not going to look at the whole thing, but just see that it has an entire list of, event manager has 3 dependencies, desk manager has, can't count that fast, and some more interesting, I won't say more interesting, but there's a whole tool note here that covers all the details. I think one of these others, some of the later tools, I guess there's like 3 or 4 tool dependencies. Yeah, so tools depend on other tools. Any questions so far about that? If any details need to go into that. All right.
For quick draw auxiliary, they just ran a numbers then, pretty much?
Oh, that's a great question about quick draw auxiliary. No, I do not believe quick draw, when they started quick draw auxiliary, no, they do not. I do not believe they actually ran out of numbers. The quick draw auxiliary is not a ROM-based tool. So quick draw is ROM, quick draw auxiliary is RAM. So they had a separate set of routines that probably weren't ready when they had to burn the ROM in advance. So those were all added later for debugging or what other purposes. The quick draw auxiliary is also a multi-segmented tool file. So you can load the first segment and not necessarily need some of the tool calls which have to be in another segment. So they did some special tricks like that to keep, because of 2GS initially, well, one can argue if you just buy a ROM 1, you don't have enough memory for most applications, unless you have to buy more memory. But so, obviously Apple IIgs, for those who haven't, beefed them up, have, memory restrictions. But for those who, buy, there's now 8-bit. We can still buy 8-bit cards and beef memory in the 2GS. So practically, any 2GS out there won't have memory restrictions. So these tool call restrictions that were made during the early development of the Apple IIgs, I would like to argue we don't really need to care about, since there are options out there to increase the number of tools or increase your memory and whatnot. But they were still all designed for keeping your memory use tight, or working within restricted memory environments rather. All right, I think I answered your question. Did I? Okay. Any other questions so far? All right. So that was an example of the TechNode, and of course you can Google it and download it. It's available online. All right. When accessing a tool call, and for those who have developed, this is a lot of old material, but there is the term is a vector memory, which is just a jump routine that is guaranteed to be in the same location memory. So if Apple ever recompiled the ROM, which they of course have done at least twice, or 3 times rather, the actual tool call can be somewhere else in memory, but you have a guaranteed location that that the application can then access to call tools. So whenever an application calls a tool, you need 7 bytes of memory that contains 2 instructions. One is load the X register with the tool number, and then you do a long jump to E100000, and that will actually call a tool. So we actually don't really care where that actually goes, because it's always going to be, so the vector is always going to be the same point of memory. Apple also added an additional tool call routine that if you wanted to call a tool, and then you wanted your application to run some sort of additional routine within it, there's an additional tool, additional vector, at E10004 that if you set up, you pass all the parameters on the stack, which we haven't talked about yet, pass the parameters on the stack to set the tool call. But if the first item on the stack that you had pushed in before the parameters was a long return to a routine, that routine will be called after the tool call runs. For those who care, did that make sense? It's fully documented in all the tech notes that I'll be highlighting.
Before even the parameters.
Yes, it's actually before the parameters, correct. And so touching on the parameters, as I talked about making the note here, some tool calls have a return parameter, so you may need to allocate 2 or 4 bytes of memory. Well, most tool calls will be 0 bytes, 2 bytes, or 4 bytes. There are a few tool calls that were developed that have a larger return space. The toolbox reference manuals will mention, of course, you refer to that how you do your tool calls. So you have your return address, then you have your arguments for the parameters, which can be no parameters or whatever the tool call reference says, and then you do your the LDX and a long jump to, or long JSL to E1000. When developing, I'm talking about developing code. So I have an example here, well, not less than an example, but more of a description of how to access this in C. I'm going to try to be pushing, C as the primary language throughout KFest. Occasionally, the last screen I did, speak assembly, and there are times where you have to understand the actual assembly of the system. But the nice thing about C, well, of course, one can argue portability, but I like to argue, that this is a language that is used on so many other computers that if one learns C, if one has seen knowledge of programming in C in one computer, then it's applicable to other computers. So if you're learning the 2GS, you can apply it to other computers. If you learn another computer, it's applicable to 2GS. So I think C is a much better language for those who want to, use the experience of 2GS programming, and it's more practical in today's world than, say, assembly or Pascal. So the C example, it's much easier actually to call tools in C that, well, I wouldn't say easier, but ignore that line. The point, to call a tool call in C, you first pound include the header file for the tool call. I just look at the .h files in Orca C and figure out which one is the right name for the tool set that I'm using. Look at the toolbox reference manual for the parameters, and of course it's recommended to check for any errors, to see if that tool call can generate errors and handle errors. With assembly, which I didn't write down here, there are macros that Merlin, Orca M assemblers provide, and it's usually underscore tool name, and that macro underscore tool name does have 7 bytes of code, the LDX tool call number, and the JSL to E10000. Making sure this is the primary window. All right. I was going to add something else there, but apparently I didn't write it down. So if there's questions, I'll certainly answer it. So jumping ahead, user tools. So I briefly talked about system tools, what a program does to access them. For user tools, Apple recommended that if a tool set is to be written, third-party developers should only write user tools because system tools are reserved by Apple. Well, you know what? Apple hasn't updated the system software since 1992. Syndicom had taken over the APDA/DTS services. Syndicom is still handling that level of service. Syndicom sells meaning the documentation that was originally sold back in the day. And they have taken on roles, they have continued the role of what DTS used to do, the developers something. Tactical services?
Technical support.
Support, thank you. So two of the functionalities that existed at the time was handling file types and tool calls. And so when I was involved in when I wrote my first tool call in the late 90s, I worked with Syndicom to say, I'm doing this, can you please bless me an official number? And so that was how I got the official tool calls for the tool sets that I wrote. All right, not far enough. So writing your own. So Apple has documented how to write your own user tool, which is in which there's two sources. One is in 2GS Tech Note number 73. And the second is Appendix B of the Toolbox reference, which I spelled incorrectly there, Volume 2. And they'll touch on where I was asked about the differences. I got Tech Note number 73 here. The Appendix B was actually the better information about the difference. Very close in the there it is. So Techno 73, and I'm trying to remember what the difference was. There was, that's right. With a user tool, the user tool, you don't use load tools. When Apple's, so. Actually, I will see if I have that on the second screen. I will hold up that for one moment. All right, I didn't have to write that down. Ah, there it is. Yes. So with user tools can be stored. User tools doesn't necessarily have to be stored in the system tools directory. It's sort of recommended for system tools to be stored with the application. I can think of, in the case of if you have an AppleTalk server and you want to run apps with AppleTalk servers, you may not have write capability into the systems directory. So applications would have to be within user space. So a user tool would have to, could be in the same directory where the application is. So an application would then say load tool call from the current directory where the application is, which is prefix number 9. And so if you load it there, then you're basically loading that file into memory, but it's not using, it's not the load tool, so then you have to read the memory and say this is the TSPTR, which is now on here, and say this is the TSPTR and the toolset pointer table, and then you tell the tool calls, here it is, and then the remaining elements of the toolset will look just like a system tool. So the actual tool files is identical, but the way the application loads it will be slightly different. And so I will be showing examples of tool calls that I have written, or tool sets that I've written, so you can see how I have done it. And even though those were system tools, they're 100% applicable to what a user tool would be as well. I've lost the mouse. There it is. All right.
Geoff, just a quick comment.
Yes.
One of the benefits of keeping user tools in the application directory is it doesn't matter what number you give it.
Correct.
You can have 10 different user tools named number 1 that all do different things if they're in 10 different application directories.
Right, exactly, and to make a note, and it's also often recommended to not name that, say, tool 001, but if one was like a joystick routine, you call it, joystick tool. It could be number 1, and you use it with application. So that application knows that joystick tool is number 1 for that application, which also means, well, I won't say that. But another application could have like time tool, and that would be number 1.
Okay, but things like, not that anybody really uses that often, but like if you get a switch it or something, you can still only load one user tool to that number
Right.
at a time, so those could not work together.
Right, so you couldn't have time tool number 1 and joystick tool number 1. When one assembles or compiles the tools, you are hard coding all the tool code numbers in that code. So yeah, you can't dynamically say that this tool is number 23. Or you can just name the tool, tool number 1 if you want to just do that. But Apple recommended that it becomes a more descriptive name. So yeah, so when I'll show you the tool, there'll be a tool called table, and then you have all the functions of the table, which are the actual code. All right. So I was also asked to talk about patching tools, and this is something that I was hoping to at least do an example, or over the past couple of weeks to at least test out. And well, real life happened, and I didn't have time to do any experiments. But there's plenty of documentation out there for patching tools. So there's basically three proper ways for patching tools. The 2 are proper, 1 is less proper, and everything's documented. So the method that is recommended the most is pre-patching. So there is as I mentioned, I'll show examples. There's a table of all the function calls. So that call is the pointer to where the function begins. If you then change that pointer to a different memory location, say to a function call in your code, then when that tool call is run, it then runs code in your memory space, and that's essentially the patch. So it doesn't actually modify the code that exists in ROM or RAM, it just replaces it and runs your code. With a pre-patch, it's recommended that you run your code and then you run the system code. I'll mention that in a moment. There's a tail patch, which is opposite. The patch is, your patch gets run after running the system call. The reason why Apple recommends pre-patch for the primary patch mechanism is there are some tool calls that have existing patches that check the return address of where they are run, and it will does different things based upon the return address. So one has to be very careful if you're going to do a tail patch, because there are some patches in the system that check for that return address. Did that make enough sense? It's also fully documented in the two tool sets, 101 for patching the toolbox. As I said, avoid tail patching. And the final entry was patching the tool dispatcher, which is basically the E1000 stuff. There's two. I mentioned the 2 dispatchers, the E10000 and the E10004. Since any program or system utility can access those, you would have to patch both of those. And basically, every time a tool call runs, it basically runs through your code to see is this tool number my code. Otherwise, if not, then it sends it back to the system and let the system handle it in its normal means. Tool call dispatching patching is not recommended because every tool call will then be affected speed-wise with your code. Questions about that? All right, so that's the end of the PowerPoint stuff. So stop this.
Will this be posted online?
Yes, this presentation will be put on the KFest website. I don't know why slideshow doesn't stop that. Escape. How about that? There we go. That's just later. All right. Close this first. So the code that I've written. So I have, I actually have one more page on the presentation. The last page of the presentation, which will be posted, will be the URLs to source code for the tool calls I've written, the hash tool and time tool. The hash tool can be found at hashtool.gwlink.net and have a URL that takes you directly to the disk image with the source code for the time tool. I haven't actually verified that disk image is actually complete, so let me know if it isn't, and I will correct it, since I just copied it onto a public place earlier today. All right. So I'm going to show examples of code. All right. So I'll do the hash tool since I like that one. That one has a lot of, it was more sophisticated. I probably spelled that wrong. Hash, yeah. So I like my GUI editor. I like my VI in Unix, but I like my GUI editor in the 2GS. I haven't figured this out. All right. So tool 128. So this is the base. So this is the tool call. I think I have a GPL. Yeah, I think my GPL. Yep, I GPL this. So I got the full license here. That's just a bunch of, that's a global data for the tool set. The hash tool is for it's used for generating hashes, MD5, MD4. I actually forget right now all the other ones I've added. Did a bunch of additions over the past couple of years. Lost the mouse again. Here. So so the data is actually the GEQs is just a global defining variables, and this is the beginning of the this is the beginning of the tool set actually on disk memory, on disk and in memory. So it's we have an account of the number of tools. It needs to be the number of routines plus 1, and here's pointers to all of the tool calls. There's apparently I skipped a few things on my presentation. Oh well, it's all here. So the first 9 tool calls are the same in every tool set. There's a boot init which runs when the tool is initially loaded. You have the tool startup, which is so you first load the tool, and then you have to start the tool. If you don't start the tool, then the system doesn't acknowledge that it exists. Sometimes in ROM you can, but you're not supposed to. For RAM tools, it definitely doesn't exist at all. So you run the startup routine. You can use that to allocate memory. You can use it to set up direct page, and add some direct page for the tool call. Several uses for that. Shutdown is used to clean things up. You have the version number. So this is sometimes as tool calls get updated over time, some programs expect a newer version than older version. Some people may have an older version on their system, and so you want to check the version number to make sure that it is new enough for your application. If your application only uses certain tool calls that are only available in an older version, perhaps you just want to use an older version number for the comparison. Reset, if the user does a reset on the system, then you may need to handle something special, like if you have a file open, you may want to close the file. Applications should never call reset, that's always called by the system. And status is used to identify is the tool call active or not active. And there's 2 reserved tool calls for future expansion. I guess we'll never use them, but say you waste 8 bytes of memory. I don't care about 8 bytes of memory. And then you have your tool call. So this is tool call number 10. The tool calls are going to be a 16-bit value. Beginning, so it's a 16-bit value. The high byte is the tool call number, and then the low byte is the tool set number. So with my tool being, this is tool 128. So and this is number 10 decimal, which is OA hex. We pretty much always use hex nomenclature when we're talking about tool call numbers. So this is going to be OA 80 for this tool call number for MD5 and NIT. And so this is OB80, OC80, etc. I'm sure Apple had optimized this for some other reasons why they made the numbering scheme that way. Okay, so I have MD5, MD4, MD2, and SHA1, and just clearing stuff. The source code is there, and then I very happily documented where all the stack pointer is, and counting. When I first wrote this, I really had no idea what I was doing. So I look at this now, I'm going, this is just so obviously makes sense. But for someone who has, has not worked with this level of detail, this is very nicely documented. Since I had no idea what I was doing. My tool calls were originally written in assembly. The hash tool call has since been expanded to include C routines. So when I added the MD2, MD2 was a user contributed function of the tool call. I didn't write this. This was contributed. I can't remember the guy's name who contributed, but if I open it up, it'll remind me of who it was. If I was smart. Okay, it's in the release notes of who contributed this. So with a little, I had to tweak the code a little bit, but I gave him full credit. And so we have C code to we have C code as a tool call, so we don't have to actually write tool calls in assembly. And I'll touch a little bit more in in tomorrow's session, but there is no, if you right now there is no way to write a tool call completely in C. There's no pragma in C that allows, in Orca C rather, that allows for that. You'll have to do at least a small assembly stub. So if anybody's really curious of doing a full C tool call, I have no problem helping anybody with the small assembly stub to make it work. But this is an example of, the assembly stub exists because, the first part of the code was assembly, and then I'm sort of skipping where the stub is and where the C is, but I'm proving that, at least C can be used for the tool calls. There's some trickiness here where C has parameters backwards from assembly. Internally, the way you code it, you have to code it reverse it because internally it reverses it. So if you want the parameters to be accurate, you have to use this parameter. Actually, databank was for something else. The databank one is because the tool call is going to be running a different databank for the application. You have to do databank 1, and there's databank 0. That's more fun 2GS stuff. But I thought I had to do something special for assembly or for our parameters. That's all in the code. I wish the 2GS screen was bigger than 15 lines. And VI, much faster search for stuff in VI than I can with this, but So I call that C code. I have SH1. I can't remember if I added anything else after SH1 for pending. Oh yeah, I have another. I have some stuff at the end. Why did I do that? I can't remember why I have that there. If you understand hashes, it all makes sense. It's just, oh, indeed. I can't remember why I did this. I did it for a reason. If nothing else, is it cool to see assembly and C mixed together and having a working environment? There was a question.
It'll come to you too.
I'm not gonna actually. I'm not going to look at this anymore. So I'm not prepared enough to talk about this. But there was a reason for this.
So when your routine is called, the stack is almost the same. There's just some extra stuff from dispatcher. I see you have like RTL 1 and 2.
Oh yeah, that was because I didn't know what I was doing when I wrote the code. That's what all that is. I guess 15 was earlier, so I guess I inserted C somewhere in the middle of the code and they ended with assembly. I think I did that just because I didn't know what I was doing. Oh, I did this because I had problems making the banks too big. So with all this code, my program bank became more than 64K. So I had to split code across multiple banks. So for some reason I said I'm going to put some of the assembly code at the beginning, some of the assembly code at the end. I could have just combined them, but I didn't. And I guess I wasn't certain if I didn't end on assembly, if things would break. So that's why I just split things up and made it more insane. That's why I did that insanity. I never tested it any other way, so it probably will work if I didn't do this, but I didn't want to go through the hassle of seeing it fail and then doing it again. So the RTL is just that's a good question. I have RTL 1 and RTL 2.
That you have from your diagram, so I guess one is the actual application and one is the dispatcher.
I have to sit down. I don't want to spend the time here, figuring out why I wrote that. But if you really are curious, bug me later, and I will sit down and figure out why I wrote the code this way. I might have used this. Could be a call. That's MP2, isn't it? Yeah, I can't think of a reason now. This is not because of the E1004, E00100. That's completely outside of running the tool call. The two vectors will call tool calls the exact same way. So you don't have to worry about that from a tool call perspective.
Are user tools not called through a different vector?
Sorry?
User tools are called through a different vector.
Thank you for asking that. Yes, or mentioning that. So I did mention about the E10000 and the E10004. There are identical vectors for user tools. So you have E10008 and E10000C are the equivalents for user tools. Thank you. Yes. All right. So that's an example of a user tool. Time tool is a bit more clunkier, but at least it was written correctly. When I mean correctly, the original implementation, I couldn't figure out how to do the stack parameter passing correctly. So there's a lot of wrong ways of doing it that has since been corrected. And if you want to see how to do it in assembly, that's a very nice way to see how using a direct page indexing for parameter passing, or through not parameter passing, but accessing data on basically accessing the data on the stack through the direct page means. So I think the code's elegant, but that's the only way to do it. The right way, rephrase it, the right way to do it. But it took me a while to figure that out. All right, so that's tool calls, and the next step is going to be patching. Any questions so far about this before we jump in patching?
Are tools reentrant? What context does it say to call them? In other words, can I have a tool set that calls another tool set? Can I write a driver or an FST that calls a tool set? Can I call tool sets for interrupt context?
Let's see if let me see if time tool. The answer is yes. You can have tool sets called tool sets. If you remember earlier, I talked about the dependency of tools. For example, the text edit. I can't think of examples of text edit. Window manager. Window manager tool call. It's dependent on quick draw. So window manager will it has to draw on the graphic screen. Therefore, it has to go through the quick draw tool set. So that's an example of there'll be routines in window manager to then call quick draw to do stuff. That was the first half of the question. Forgot the second half.
Can I call tools from interrupts? Can I call tools from drivers? Can I call tools from FSTs?
FSTs. If you ask me later about FSTs, we can take a look. FSTs are,
I don't think so.
because the FST is for device, it's at the device level. I'm not certain if there's any reason one wants to be honest. Because FST is for disk I/O. I can't think of any reasons why an FST actually needs to call a tool. So I would say that's a good question. If you ask me later, we can take a look at things. Well, if you had two other things, drivers and with drivers, yes. The short answer is yes. The print manager, for example, is the printers are considered drivers. So when you print to an an image writer, that's considered a driver. And so that print driver for the image writer does call tool calls internally. You can draw dialog boxes, font stuff. Yes, very much so.
Interrupts.
Interrupts. This is where interrupts change a lot of things. The thing about interrupts, and this is actually a question. This is something I was actually going to point out in my next session for tomorrow. I'll probably repeat it. I may repeat it again, or may not since I mentioned it here. Because an interrupt can occur rather from within a memory manager call. So you can actually interrupt a memory manager allocation call. You have to be careful if you want to call a tool call during that time, because another tool call could be doing some memory manager allocation. So there's a busy flag, memory manager busy flag you can look at to decide if this is something that you really want to do during the middle of interrupt. But if you check the busy flag and see that it's not in use, then yes, it is safe to do. I guess if you did an interrupt with a tool call, that's a good question. Because most tool calls, the 2GS, going back a step here, I'm going to go slightly geeky, technically about stuff. The 2GS is not reentrant. The tool calls are not reentrant. So if you interrupted a tool call and then call that same tool call, you are it's using the same memory. So the short answer is I probably wouldn't do it from interrupt, just because of reentrancy limitations. But if you take advantage of the busy flag and you look at the busy flag and see if it's not busy, or if you use the busy flag as my tool call calls the busy flag, and then you check the busy flag if it's busy, then you don't run the tool call. But if it's not busy, then you can call the tool call. So there are mechanisms within the GSOS/toolbox environment that you can leverage this and know when to do it safely. There's another hand.
I was thinking on FSTs, I could see things where, for calling tools, like you could, if for some reason you need to connect to some sort of encrypted network file system or something.
Ooh, I like that concept.
Because you could need like the hash tool, you could need a tool for handling the encryption cipher. I forget, is Marinetti using any tools for the TCP/IP?
Everything is internal for that. So there's some duplicate. So yeah.
But you could need some tools from an FST if you're trying to do some stuff.
I said I like that concept. When Apple did Apple Talk, it uses a DES or something like DES. They have their own copy of DES within Apple Talk.
Okay, so they're explicitly not using tools.
If I remember correctly, yes. If I remember correctly, I would be very hesitant. I would probably follow Apple's example and do everything possible not to call a tool from the FST.
So do everything in the FST or the file system driver, or the device driver.
Yes, I think I would. I think I would. Yes. Yeah, I would need to think a lot more if I would try to do something more crazy. Yes.
Yeah, I wouldn't. I'm not that crazy.
If someone's a novice, you have to do a lot more work. Short answer. Anything else?
You gotta be crazy to try and delve into the FSPs anyways, because it's not documented on how to write.
It's not officially documented by Apple. It is, I would probably say, poorly documented as best from Antoine. I'm not sure how to pronounce his last name. Vignal, maybe. Apologize if that was really horrible. He has documented some FST stuff. So I would use that. Well, I would say anybody looking at FSTs, you have. That's the only document out there, and that's probably the best we have so far. All right. And it's going to do patching tool calls. So the example. So I'm actually going to. So I was half expecting I wasn't going to be prepared to, well, I phrased it this way. I was hoping I would have an example done, and I said if I didn't have an example done, I have a backup plan. So we have to use the backup plan for patching tool calls. The backup plan is going to be a very limited example of pre-patching, and it was written by Jay Krell back in the 90s. So his code is on the Golden Orchard CD in the programming partition. It's Golden Orchard programming MISC, and his code is in MISC A patch. So I copied that onto my environment here. So I don't have the CD into the Golden Orchard CD. I'm too many directories down. So A patch. So I actually want to say I actually don't know his code, but this is an example. He had his code. His only tested code is assembly. He had ported his code into Orca C, but if you read the valve documentation, it basically says that the C code was not tested. It's just an example. Says somewhere here it's not tested. It's documented that's not tested. So I probably wouldn't test. So I wouldn't use the C code with any certainty. But so got the assembly code here. Come on, open up. And actually, I haven't really gone through this to see exactly how it works. But when you do a patching, you have to patch the boot init tool call, and there's going to be a pre-patch somewhere here. So he says, it's poorly documented, but there's going to be a pre-patch routine that is the patch, and just reads through the code and it does all the setting the tool set pointers and whatever else has to be modified.
Did you say that he just wanted to patch boot init, or that you have to?
I'm sorry, yeah, you have to. Apple documented that you have to patch the boot init tool call. I can't remember if they documented why you have to do it, and I can't think of the reason why you have to, but it is. So this tool call is a good example of what was done during the boot init of why it was patched.
So you have like a whole chain of boot init patches, and if you patch other calls.
Apparently that's what because I haven't tested this, I think the answer to that is yes. I'm sure that's what would happen. Yes. So basically saying it exists. I can't really intelligently talk about this, but to prove that it actually works, So he has patched. I'll go back to about to remember which, since I can't remember which tool call he patched. We'll cheat and read the. Oh, sorry, wrong. Open about. So he patches. Let's see. Some on the top here. Okay. So not listed there.
I thought that's further down in that document.
Flippers. Oh yeah. Apple's call code. Don't call Apple. That's something.
Yeah, like scroll down a page or two.
Flippers. That's the end of the listing.
Yeah.
You asked me an hour ago, I would have memorized it, but I apologize that it's not obvious. Sheet defined. Let's patching. I changed the patch. Post event to. I don't know. He has to patch something. And we see, boot init stuff, so he is patching. So it's very much a tool set patching. As I said, the code's out there. So we'll. So this make is actually not a Unix make. It's not a make file. It's a Orca build script, but he named it make, so it looks like a standard Unix command. So you make it. So we compile the patch code here, and then there's a hole, and then he adds that into a permanent initialization file. So we cd to C example. Make this. And I had to modify, oops, I guess everything was already built. I had to modify the code because the default code assumes J's Orca environment, which is using HT2 /Orca/source. So unless your hard drive is actually laid out exactly like his, you'll have to modify the code. And he also is using a custom command duplicate instead of the copy command. So I modified the code for my environment here. So I've copied it. The program is now been copied to the system setup, and I'm going to reboot the system to restart my environment and get the new system setup running. And his patch will flip the cursor on the vertical axis. If you hold the mouse button down. So holding the mouse button down, it flips. So everything still works as you expect. You can still double click. But this was an example they showed that he can patch a tool call and he did it safely and following the Apple documentation. Making one final note about patching tool calls. The pre-patching is often, when doing pre-patching, it's sort of more likely expected that you're going to do this within an application. So if you have an application and you know that you want to sort of tweak a tool call just for your application, you may not make it. You may not make it a full system, a permanent initialization kind of a routine, but it'll just be within your application. When I was asked about patching tool calls, I'm pretty sure it was thinking more along the lines of, oh, how does GSOS patch the ROM tool calls, for example. So touching on that for a moment, with the tool calls being in ROM, there's one or two bits of details which I'm a little hazy about, since Apple hasn't documented that detail. But when you do a ROM-based, so if your tool calls in ROM and there's a bug in the tool call, you obviously can't. You're not going to just be rebooting your ROM. And Apple, only made one new ROM during the lifespan of the 2GS. That was from the 00 to 01. Well, when I say we knew, they gave a free update to that. And with the ROM 03, they didn't give free updates to the ROM 03, mainly because they doubled the ROM and it wasn't going to fit in the ROM 01. So Apple has a patch mechanism within the OS to look at. So obviously in the ROM there's going to be a tool call pointer table. When you do a startup of a tool, that pointer table gets copied into RAM. So when GSOS patches tools on boot, it actually looks at the RAM-based pointer table, copies that, changes where it wants to changes the memory locations for the tools that it has replacements for, updates the table, and that's how GSOS patches tool calls. So that's pretty much my entire discussion. I'm not sure how over time I am. Any questions? Let's start with Daniel.
When are you allowed to do a pre-patch? Can you do it at any time, or do you have to do it before you do a startup, or?
Good question. Apparently GSOS does it before. For the ROM-based, it apparently can do it anytime.
Right.
I guess it's anytime.
Like memory manager has started. I know.
This is the areas of details that I know very little about. I just know basics of how some of the stuff works, and I don't know that detail.
Okay. Got another one too. They have RAM tools in the system folder.
Yes.
But they also have a system set up like TS2 and TS3, these
Yes.
permanent initialization files.
Yes.
Why can't they just load a new RAM tool and replace those other calls?
Thank you, Daniel. That's a wonderful question. And if I was in today's world, since memory is memory is relatively cheap, I would have done throw away the ROM tools, and I would just build a if I was Apple, I would build the whole tool file, stick it in the system tool file, just load that, and not deal with this stupid patching mechanism. Because we're looking back in time before accelerators, and memory was much more constrained, 1 meg 2GSs or less. Apple said, we will only fill RAM with just the tool call that was modified, so we don't have to load the entire tool. The other reason is when a tool call runs in ROM, it runs at 2.8 megahertz. When tool calls run in RAM, it's 2.5 megahertz. So there's a small increase of it's faster to run in ROM. Argument with an accelerator, you're not going to see the difference. So I would say, in today's world, I don't like what Apple did, but they did it because of resource constraints at the time. Any additions, Daniel?
I don't know. I'm going to ask a question.
There's the two of you back there, but
if, like, I know between round 1 and 3, like, I think Memory Manager say was updated. Is that true? I don't know. This is an example.
There's a tool note with release notes. I believe tool note number 10 or 12.
Right. So if you load System 601,
yes,
do you end up with the same equivalent,
With
Or are there certain things that cannot be patched in the ROM where it's a little different? Or
Yes. The answer is yes. Unfortunately, there is a node bug in ROM 01s that, unless you get this one softest GS patch, and of course, if there's a memory manager bug in the ROM 01, and I can't remember if it was fixed in ROM 3 or not, but that patch, but you could potentially mangle memory before that patch gets loaded. So after you load the patch, then the patch takes care of fixing the bug. So that sort of half answers the question where I think you were going. I'm not sure if I answered all the points.
but I mean, memory's already been allocated, and so they can't change the data structure or things like that. You can't do any massive updates.
Easily, no. I don't think so. I wouldn't. So let's go back to the back of the room.
You said user tools can have identical numbers between applications. I guess, does that mean that DAs and other concurrently running programs cannot use user tools? They can have multiple DAs open at a single time. So therefore, they couldn't each have a tool once.
That's a good question, and I should know that before my session for tomorrow, and I don't. I don't know.
Yeah, in the case of a GA, the tool would probably be stored with the desking customer, like in a desking customer folder, so you don't want to duplicate stuff there.
But it's the toolset pointer is common across all applications, so no. I would say don't. Yes. I would not, and I think we would break things if you try to do that. Yes.
Okay.
Yes. Was that the only question?
That was my question.
Okay, Jim.
Just a stylistic thing. You were looking at code. Can you go back to where you were looking at code? It's not particular any segment of code, but I noticed like you'd have a box, a comment box, before a section.
Yes.
You can find anywhere where you do that.
Assembly, which is what you probably saw. There's assembly there.
Yeah, something like,
Oh, the small one.
I noticed you have like a, what would you call it, an address, name.
Oh, the RTL stuff.
Left column. Yeah, and you'd have a comment box before the address name, right?
Go to the other file, the 50, which might be closer to what you're thinking of.
I haven't looked at my.
Okay, it's above the. I'm still not. This was one example that I had. I'm not sure what you mean in terms of.
Well, you had a comment and then you had a section below it. And so the comment preceded the section, right? That's the style you preferred.
Oh, putting comments before code versus
Yeah.
putting comments after code.
So my question was the name I forget what you call it, the tag, the name of that at that address?
Yes.
Was that a section or was that just out of place in code?
You have to. Okay. There's a lot of. It depends. This is where you have to know Orca M. In the case of Orca M, this is where you have to know Orca M. If here, for example, because I'm using a start, this name is part of the Orca abstraction level. So this is a start segment. You can have data segments. You can have, I can't remember them all right now, but that's just a segment name. So this is not. You can also call, you can reference segments, you can JSR to a segment or JSL to a segment, yes. Within a segment, so this is essentially the global view of a segment, and then these are private addresses.
Okay, 'cause I was
So it
thinking-
depends on your level of abstraction.
I was wondering in general, without knowing the details, if having the comment box before a segment, if that segment is a discrete segment with a beginning and end, your comment box actually falls in the prior segment.
No,
No?
it'll be the comment. The comment will be for the segment. So if you put a comment box before a segment, then the comment's for the segment. If you put the comment box before some sort of address or section of code, you assume that comments is for that section of code or whatever.
Yeah.
I would like to think this style is relatively close to professional practices.
Right, right.
When I was arguing, when I did this, I didn't know what I was doing, but I had the CS classes, but I won't necessarily say this is the best example, but I would argue that someone who understands the code
Yeah.
will be able to follow the comments very easily.
I agree, having them before it and having this segment, when you look at it, is clear.
Thank you.
know.
Any other questions? Yes.
Maybe it's a question, but what is the advantage of the user tool versus writing a library?
Thank you. Yes, I wanted to make sure I did cover this exact point. I have a very biased opinion about this. And biased opinion is partially because 20 years later, looking at modern day systems and with computers, with 2GSs, with accelerators, and you can pretty much assume that 2GS will have an accelerator and memory and lots of stuff. I would like to argue I would push the concept of libraries before toolsets. There is one absolutely good reason for toolsets out there. That good reason is there are multiple development environments. You have the two main environments, Merlin and Orca. Merlin is just assembly. Orca has C, Pascal, assembly, a lot of others. So because there's multiple environments, tool calls make sense because I don't know of a way of taking a C library and calling it from assembly or Pascal. So tool calls make sense for a multiple environment and a multiple language. I'll use the term environment again.
Whereas you could do inline assembly with C or something like that, but you can't do that.
So because I would like to say, if we start changing coding for the 2GS and make it more C, and make C the standard, and unfortunately Orca C is commercial, so it's hard to say that we should make that the standard because people say, well, I don't want to spend the $30, $60, $100, whatever for Orca C. It's hard to say libraries is the right way. So I would 2 years ago I said libraries is the right way, but because I was asked to talk about toolboxes, I would say toolboxes are a good idea. But I still will argue libraries are the right way, only because I like C. I think C should be the proper language for future development.
Can you recompile a library, like update it without touching the application that calls it? I thought it hard-coded like offsets.
Libraries are statically compiled on the 2GS. There are no dynamic libraries. There's no support in GSOS right now for dynamic libraries. If you look at the details of GSOS, if you read through the OMF structures, it was designed to include support for dynamic libraries, but the 2GS loader does not have support for dynamic libraries. And that's only answers half the question. I can't remember why I wanted to make another point.
So basically, the tools on the GS are the same as
That's the same, right?
URL.
Right. So tool calls are conceptually a dynamic library concept, except they're not libraries.
I was just saying that would be an advantage of a tool if you shared.
Oh, right. Yes.
To share a library I think you would have to rebuild all the using applications to be updated.
Or we modify the loader to actually support dynamic libraries and then use that mechanism. But then we have to decide where do we put dynamic libraries in the system directory structure, which there is nothing in place for that at this time.
The other problem with libraries, and the reason why Microsoft pushed DLLs is the fact that if it's the same code that's going to be used by lots of programs, rather than having it compiled into lots of programs and being on your hard drive, 50 times and using up that much memory with all the programs loaded, you can have it loaded once.
Which is the same, tools are the same way, and you have the same problem with
Yeah.
tools and libraries, or DLLs rather, is version hell.
And I hate to cut it short, but the pizza's here, and we know that hot pizza is better than cold pizza. It's sponsored by Juice GS, and just there's a new session we just added for tomorrow night. It's going to be around 10:15 p.m., and it's going to be on Firefly and Serenity for those of you who are fans. We have Brian Weiser here, who's done his own documentary and been on as an extra in there. So it'll be down here tomorrow night, 10:15 to 10:30, around there. And give a round of applause for Geoff. Thank you, Geoff.